Welcome to this story. We're going to analyze AC circuit in UTME. I'm going to teach you everything you have to know on the question we'll ask. Now, they will ask you question under capacitive reactance to find impedance, to find supply current, and to find power factor. Now, this question here, I'm going to expand it to other questions you may be having. Here we have an AC supply of 240 volts. Is connected across a capacitor of 5 microfarad and a resistance of 50 ohms in series at 400 hertz. Find the capacitive reactance, impedance, supply current, and power factor. Before we draw the circuit, please subscribe to my channel and like this video. Now, the circuit is always drawn in maybe a square, depending on how you draw it, or in a rectangle form. All right, here I will say that there is a what 240 volt. This 240 volt voltage are always written or represented at the bottom of this circuit. So here I will clean it and draw something here. This is my what voltage, and it is what 240 volt. V represent the volt. Now it is connected across a capacitor of 5 microfarad and a resistance of 50 ohms. Across means what? If you're on the side of a melody you want to cross, it means that what? It is at the opposite side. So this is connected across something here, which those things are what? Capacitance and what? Resistance. We are going to put capacitance over here, and this capacitance is what? 5 microfarad. And again, we have resistance as from the question, connected across a capacitance and a resistance, as you read from the question, and this resistance is what? 50 ohms. Now, before we calculate, I want you to understand the theoretical aspect of what is going on here. Remember, resistance does what? Opposes the what? Flow of current. This AC circuit contains only resistance and capacitance. There are some circuit that contains both resistance, capacitance or capacitor, and inductor. So this one has only two, which is what? Resistance and capacitor, excluding what? Inductor. Now, under this circuit, resistance here, which is 50 ohms, is not only what is opposing a current. There is a resistance under this capacitor here opposing a current. There is also an inductor. Assuming this contains an inductor, it is also what? Opposing a current. Hence, we are not going to regard resistance as the total what? Opposition of current here. The total opposition of current in an AC circuit is what we call impedance. Impedance is represented by Z. So this one here is now the total opposition of current in this particular circuit, and not just the resistance you have here outside. Now, what is capacitive reactance? Capacitance is represented with C, where capacitive reactance is represented in this form. Inductor is represented as L. There is no inductor here. We could have put in it here, but this question does not have it. And inductive reactance is represented in this form. In our next video, we are going to include an inductor in it, but I'm going to show you the question after this particular question solving. Now, capacitive reactance, as you can see, is represented by this sign over here. It is equals to 1 all over 2 pi fc, where f is the frequency and C is the what? Capacitor. Now, in this our AC circuit, we do not represent the what? Frequency. The frequency is given to be what? 50 hertz. So 50, or the frequency, are always attached to the voltage, which here we are going to put as 50 what? Hertz. Is always attached to what? Voltage. Now our circuit is complete. So to find this, we are now going to put it as 1 all over 2 pi. We represent pi as multiplied by 22/7. Now, frequency, which is what? The 50 as we have it, and multiplied by the capacitor. Capacitor is what? 5. Now, 5 microfarad. Micro is a unit that is equals to 10 raised to power -6. All right. Now, multiply by 10 raised to power -what? 6. But here, let's put in the 5. So 5 is the what? Capacitance, and because it is in microfarad, micro is times 10 raised to power negative 6. So this is our what? If we calculate it, we're going to get the what? The capacitive reactance. And I've done that. I've calculated it and sum it up to be capacitive reactant. C is equals to 636.62 ohms. So it is also measured in what? In ohms. Now that is the first answer for the first question. Hence, we are going to clean this. The next one, we are asked to find the what? Impedance. Now, impedance, like I told you, is the total opposition of current in this circuit, not the resistance. So, impedance is given to be x square is equals to R square resistance square plus capacitive reactance. Why is this so? Capacitive reactance square, I mean to say. So why is this so? Because resistance, since impedance represented by Z, the total opposition of the current. Hence, to find that total opposition of the current, you are going to add the what? This resistance, which is also opposing a current, and the capacitive reactance, which is also what? Opposing a current. Because we have only resistor and capacitor, this is the formula. Assuming we have an inductor, I told you that inductive reactance is what? This in this form. We are now going to include inductor. The formula like this will now become Z square equals to R square plus brackets inductive reactance minus capacitive reactants all to square. This is if this circuit contains inductor, we are going to use this formula. Why this one is what? Inductive reactant. You will also be given the inductor value on the circuit. So here we are looking for what? Impedance and not impedance square. So we must cancel this by what? Square rooting the both side, as you can see here. So this becomes our formula for what? Impedance. So we are going to use this one because we don't have a what? Inductor. If you have inductor, we are going to use this other one. So I'm going to clean this one over here and rather use this particular formula. So hence I'm going to have equals to the root of what is resistance? Resistance is what? 50, and it is what? Square. Plus what is my inductive reactance? I've calculated it to be 636.6 2 ohms, which is what? 636.62 ohm, that is raised to power 2. Now if you work this out, 50 raised to power 2 is going to give us 2,500, which is equals to the root of 2,500, and this other one raised to power 2 is going to give us 405285.0244. All right. Now all of them has the square has been removed. So we now have to add this together and we root it. If you add it together, you're going to have it is equals to the root of 407785.0244. Now, if you now say the square root of this, and you find out that impedance will now be equals to 638.58, and they are also measured in what? In ohms. So these are what? Impedance. Hope you understand this. So in a question you have the inductor, you're going to use that what? Formula. All right. So should I clean? So we have gotten the what? The impedance, which is what? Total opposition of current. Know why we are adding it together? We're adding together because all of them contains the what? The resistance, the opposition of current, and that opposition is the impedance. Now, supply current. What is current? Current I from the formula V equals what? R.I. Are you getting me? From the formula V equals R.I, we get the what? The current, supply current. But as you know, resistance R here is not the total resistance or the opposition. The total opposition here is impedance. So I cannot be using arrow again. I'll be using that total opposition of what I have, and it is represented by Z. Hence, this formula will no longer be in this form. It will now be V equals to ZI. Whereas my I, which is the current, supply current, becomes what? V over Z. And what is V over Z? V is what? 240. And what we calculated as Z? Z here was 638.58. So you get 68, yes, 638.58. Now, if you divide this and this, you're going to have that the supply current, where is my marker, second marker? You're going to get that the supply current is going to be 0.376 ampere. This is the word supply current. And as you can see, it is under what? Ampere. Yeah, that's the units. And this is changing of the resistance to what? Impedance. That's what you have to do. So this question is going to be asked. Now the next question we'll ask is the power factor. What is the power factor? The power factor is power factor is equals to cos theta. Are you getting me? Power factor is equals to cos theta, whereas cos theta is equals to R over Z. Whereas what? Cos theta is equals to what? R over Z. Hence, power factor, which is cos theta is equals to what? R over Z. What is R? R is what? Resistance, which we have as what? The 50, and the impedance we got to be what? 638.58. That's what we got as impedance, you remember. So what do we mean? As you can see, we are using a resistance to divide by what? The impedance, which is what? Total opposition. So the resistance is opposing, and in impedance is also opposing. So if we divide it, we get what we call power factor, which is what? Cos theta. Now this theta here, we are not going to get it because cos theta is what? The power factor itself. Whereas if we are asked to get only the theta, it is another parameter on its own, which are going to look at the next question. So this cos theta, we have a drawing. It will have a drawing. I'm not going to explain it here, but in our next video we'll talk about it. So this is further equals to, as we have it here, the power factor. If you work that out, you're going to find out that the power factor is going to be something you're going to put for me on the comment section. So work this power factor out. What is 50 divided by 638.58 ohms? All right, so after you have done this, so hope and I know you will not fail any question that will be asked on AC circuit. Now look at what I want you to do here. Now let's say there is a voltage connected across a capacitance and a resistor and an inductor. All right, let's put it here. So there is a voltage, you notice our normal drawing, voltage connected. Let this voltage be 50 volt. Let me make the parameter to be very small in value, and it's a resistance over here. This resistance, let it be 50. Now there is also a capacitor. There is a capacitor. Let's make this capacitor to be 3 microfarad, or let me remove the farad so it's gonna be easy for you. The farad, no, in JAMB they will not make it to be easy, so let's just put the microfarad over here. And then we are now going to include an inductor. So we're going to include a what? An inductor. Let's put it as 6, or let's make it 50 inductor. All right, inductant. So this is it. Now in this expression, I want you to get for me, let the frequency be 50 as well. I want you to get for me inductive reactants. Inductive reactants. I want you to get for me capacitive reactants. Capacitive reactants. And I want you to get for me impedance. Impedance. And I want you to get for me the current supply. The current supply. Now you can add it. You can add what? Power factor. Power factor. So this one is also simple and easy. So the power factor formula will still be this. But now what is going to help you is the inductive reactant and the impedance, because the formula is going to change because we now have what? Inductor. Now inductive reactant is represented by what? This form, as you can see, and the inductive reactant is equals to 2 pi f L. Remember, capacitive reactance is what? Equals to 1 over 2 pi Fc. While inductive reactance is 2 pi Fl. So you're now going to use this inductor and put here the frequency and put here the pi and then the 2 pi. You work it out. So that is going to give you inductive reactance. While this one is going to give you what? Capacitive reactance. You're going to find it. Now the impedance is now going to be the impedance Z is now going to be what? It's now going to be R square. Remember, this one has square, but we are now rooting it because we cannot find the impedance square. We're looking for impedance. So it's going to be R square bracket plus R square plus bracket inductive reactant. So that inductive reactant, if you find it, you use it and put here and minus it from capacitive reactant all to what? Square. So after you have done this, let me know your answer on the comment section. Now to find the current supply, you are going to use the what? The V, which is equals to R, whereby the arrow here is not only the resistance, opposing resistance, it is what? The impedance. So we're gonna use this and find the what? Current supply. And finally the power factor. Thank you for watching. If this video seems a lot helpful for you, subscribe to my YouTube channel, share it to your friends that are writing UTME or any group you know on WhatsApp. It's going to help them. I want to see this on the comment section. Please comment and let me know what you think about this video on the comment section. Please, I forget something. In your UTME question, they will not ask you to find all of those. They may ask you to find only the what? Only the impedance. But you know that before you find impedance, you might have already know what the resistor is. You might also have already know what the capacitive reactance. So you must get the capacitive reactance to get the impedance. If the resistor consists of what? Inductor, you might also know what the inductant is. So I can minus it from what? Capacitive reactance over here. All right. Before you now get impedance. Are you getting? So there's a need of getting these two or need of getting only one. If the resistor contains only capacitor, you now get the capacitive reactant before you now use that to get the impedance. Thank you once more and bye-bye.